I'd like to introduce myself. I'm Suzanne Kern-Kana, and I work at T-Mobile. I've been in development for 10 years or so in the quality engineering organizations. And I first started using CA tooling back in 2012, and I've actually been here at CA World and I've presented for CA Service Virtualization in the past. So I'm currently the product owner for our test automation for our enterprise. So a few facts about T-Mobile is we actually run under two brand names, under the T-Mobile brand and also under Metro PCS. And we are located in Bellevue, Washington, which is a suburb of Seattle, Washington. We're known as the Un-carrier at T-Mobile because we're always redefining the way wireless is done. They said it would get... So that's enough about me, and I'm going to introduce you now to our co-presenter, Jason Job.
I'm Jason Job. Can you guys hear me okay? Okay. So I'm a solutions architect with ProKarma. Can you hear me? A little bit? Is that better? Okay, thanks. So I'm a solutions architect with ProKarma. I've been doing software development and automation solutions for about 20 years. Before ProKarma, I was at Microsoft as a senior software engineer, developing automation solutions for operating systems and network applications. With ProKarma, I've been at T-Mobile for about 3 years, doing web service virtualization, automation solutions for them. And just a little bit about ProKarma. ProKarma is a leader in IT solutions and digital transformation technologies, and offices around the world, and has been a T-Mobile partner since 2010. So I'm going to turn it back over to Suzanne. She's going to give a little bit of background around our usage of CASV Suite at T-Mobile.
So before we dive into the heart of the presentation, I first want to give you some background on our usage of CASV at T-Mobile. So T-Mobile has been using CASV for approximately 4 years successfully. The tooling is used across different functional areas, development teams, test teams, performance engineering teams. And then until Jason developed this service testing pipeline, we traditionally used CASV just as the workstation. So I just want to kind of get a feeling for you guys. How many of you folks use CASV right now? So that's about half of you, which is good. So this presentation is focused on CASV, but we're also gonna give you some other techniques that we've used that will help improve your DevOps practices around service testing. So I'll now pass the baton off to Jason, who will present the transformation from our workstation-based solution to an automated pipeline.
All right, thanks Suzanne, and thanks everybody for coming to our talk today. Before we kind of get started in the meat of the presentation, I just wanted to give you guys a couple of takeaways and how I'm going to judge success of the talk. Really my goal in sharing these experiences with you guys is so that you take a couple of new ideas and approaches back with you. And even if you don't really agree with every approach or outcome that we've taken, but you have a couple of ideas or new approaches on your side, then I'll kind of consider this talk successful. So I want to kind of set some context around the team from where we started a few years ago with CASV. And just for simplification, some people may know CASV as Lisa or Dev Test or Application Test. I'm just going to call it CASV, so when you hear that, that's just, do the replacement in your head if you're used to one of the other names. So for us, SV, the real big benefit to it is having a lot of different technical capabilities. Somebody who's not a very good programmer or doesn't know programming at all can jump right in and get started writing automation. But then if you are a programmer, it allows you to kind of enhance and expand the capabilities of your automation. And that's kind of what we're going to focus on today, is enhancing those solutions and kind of, expanding the capabilities. So back to kind of my team. What we wanted to do is start out with just a simple approach. We were all kind of new to T-Mobile. We were new to CASV. So we wanted to start out with something pretty simple and basic, just to get off the ground and get running. And so what we did was basically what the slide is saying. We used one Excel data sheet, and we're driving each of our test cases with that Excel data sheet. Very simple. All the data is kind of in one place. You know where it's coming from, how to control it, what to change. Got us started really quickly, but we soon kind of noticed a lot of challenge that we were facing with that solution. We started to notice a lot of files and file management challenges that I'll talk about here in a minute. But some of the eventual solutions that we did come up with allowed us to increase our capacity, test capacity, and reduce our team size at the same time. So pretty big wins. So I just want to take a couple closer looks at a few of the challenges. Number one is how labor intensive our approach was. Everything was kind of semi-automated. People were sort of driving the process, making the tools do the work. Kind of fighting the tools, fighting the data, instead of letting the tools and the data help them. And so that was one of the big challenges that we wanted to go and solve. Second was, we didn't really have a common process or a common script or any standards. So you can imagine, like, we're making copies of these Excel data sheets, and one team is adding a new column, another team is renaming a column, the casing is different, they're in different orders. It was kind of a mess, and really not sustainable. Hard to write tools and scripts against too, because everybody's doing it slightly differently. So that's another one of the big challenges we wanted to go and solve. And lastly, within our larger team, we had two technology stacks we were testing. One was SOAP-based, the other is REST-based. So if you're looking at a CASV script that's targeting REST or targeting SOAP, you have different controls. You're looking at JSON versus XML. And this kind of made it challenging for us to collaborate. We couldn't really share approaches or tests or really kind of collaborate in any kind of useful way. So that was another big piece that we wanted to solve. So that's kind of an overview of the main challenges that we faced. Now I want to sort of show you guys the solutions that we came up with. The first big solution was the test pipeline that we developed. And the real, the challenge that we were trying to solve with this was getting rid of this manual, kind of semi-automated approach that we were using. Part of it was our own fault in a couple of ways. We hadn't really invested in automation. We were just kind of using the tools to run our tests, and we were using them sort of incorrectly. For folks who use CASV, the workstation, the ITR mode, which is interactive test run, it's kind of designed for debugging, so you can step through your scripts, sort of see what's going on. We were using that as the way to execute our test passes. So we're doing them sequentially, one after another, running a script. Very time consuming, pretty much the wrong way to do automated testing. But that's where we started, right? So we're trying to figure out how can we help make the machines do the heavy lifting, get people out of that business of executing tests. And so what we're looking at is this notion of making it machine-driven instead of people-driven. And we noticed that CASV has a feature called CVS, which is Continuous Validation Service. And the idea behind this is you can create some tests and some suites, set up a schedule, push those up to the server, and then let the server go and do the execution work for you. You're not in the business of clicking buttons and driving scripts to do it. The server's handling that for you. So we wanted to take advantage of this, but we're playing around with it, and we're still kind of in this model of tests are changing, code's changing. we redo our tests, we push them up to the server, doing that again and again. Our code was kind of in this, a lot of churn. So we're trying to get out of that model. And what we wanted to do was just automate the process of bundling the tests in a MAR file, and then have something push that MAR file up to the server, and then the server could go and handle that. So the benefit of this solution is that we're trying to get people to be test creators and test editors, push those into a source control system, let a job and some scripts go and act on those changes, and then bundle those up, push them up to the server, and then the server goes and takes care of that. And that's what we eventually achieved by first starting out. We weren't really storing anything in source control. Everybody kind of had them on their own machines. Every once in a while, people would check something into source control, mostly as a way to back their files up. Nothing useful was happening in source control. But because we were using this pipeline to pull information out of source control, it then became kind of the focal point of where everybody was trying to do their work. Nothing got out to execute until it was in source control. Jenkins jobs would then notice changes, bundle those up, push them out. And so that changed the whole way that we were developing our automation. Before, it was just stale tests, local changes, not very well managed. And afterwards, everybody's committing all their files to source control. Jenkins is pulling those, and anything that you don't have in source control doesn't get into the run. So by doing this, basically we were able to run thousands of tests in about an hour's time over multiple test environments. Before we had the test pipeline, this took our entire team about a week to run them through the workstation, one by one, sequentially, kind of, this people-driven approach. Afterwards, we're doing the equivalent of a test pass multiple times a day in about an hour over multiple environments, which was just like a giant leap forward for us. And actually, and I mentioned this before, even better, we were able to reduce our team size at the same time we were expanding our test coverage. So our costs went down and our coverage went up. So now I kind of want to show a flow of the data through the pipeline, just to highlight how everything is kind of working together. So we look at the left-hand side. We've got our test files, we've got our data files. We store those in source control. We use Accurev and we've used Bitbucket. They both work for this process. We have Jenkins. Jenkins jobs are, they're acting on the changes, they're noticing when changes are being checked in, and they're going and executing our scripts. And our scripts are then orchestrating this, a set of command line tools that get installed with CASV Workstation. So we're using those command line tools to go and package up all of our tests as MAR files, and then we're copying those up to the server. I just want to look at the suite and MAR file creation in a little bit more detail. So we talked about this a little bit already, but Jenkins is detecting changes. It's executing our script. The script in turn is using the command line tools. Those tools are then bundling up the MAR files. But if you go and create a suite in CASV, or you go and create a MAR file, you'll notice there's some of these XML files that get created in the background. These XML files contain things like the file paths, the file names, all this kind of data around what you're trying to either execute in a suite or bundle up into a MAR file, or in CVS case, what the schedule is. So when I looked at that, I noticed that those were kind of the dynamic pieces, names, paths, schedule. And so I kind of turned those things into variables so that my script can go and manipulate those. Everything else becomes kind of a template. And then what that Jenkins job is doing is it's loading up that template, changing out the file names, the paths, the schedule, all in this kind of programmatic, dynamic kind of way. And that allows us to bundle up any of these change files kind of as they're happening. Lastly, once the MAR file is created, it's got all the contents of our tests in it, Now we just need to get that up onto the CASV server. That's pretty simple. Just we copy the file up there, and then we're good to go. It's going to execute on its own on the schedule we've set until the end time that is hit. A nice additional benefit is you can go up there and run it on demand if you want to, so you don't have to wait for that schedule to kick off. You can just go up there and do it as needed. So the next thing I want to talk about is our script engine. So our script engine is trying to solve this problem around not having a common process or common script, no standards, and having all this kind of specialized knowledge that's getting bundled into different scripts. So when I started looking at what we had across the different scripts, I noticed we were basically doing kind of a loop. We're loading up some data, doing an action, validating results, saving results, and then just going ahead and doing that again. That's just kind of the workflow of the script. And so there's no point in having multiple copies of that kind of script. It really kind of just begs to be data-driven. So what I started doing is pulling these different technology pieces from other scripts into a single script. So we have a REST call, a SOAP call, we have some stuff to drive database queries and execution there. And so that was kind of stage one. We got everything in there. But the nice thing about having a single script is all your logic's in one place. So your fixes are done in one place, your enhancements are done in one place. If you want to do, have some unit tests or something like that, you can make sure that the quality is high for your script. And everything is kind of just based on this one engine that's driving everything, rather than having multiple copies and having to maintain versions and figure out how to get somebody's cool addition from this script back into the other scripts. Kind of alleviates a lot of those pain points. And also, like I mentioned before, like these multiple technology stacks. Once you start to recognize, this flow needs this piece, you just pull those into one engine, and then figure out how to drive that component with data. So when we started adding all these pieces, we were able to save data and do response validation and allow that saved data to be passed to other steps. So then by doing that, we're able to chain multiple steps together, and now we can create very complex workflows that I'll show you a little bit in the next slide. And by putting all these things in one script, we've basically created a platform for our automation. Everything that we want to build, we put it in one place. So we've added things like Apigee tracing, Splunk lookups for request and response, MongoDB query support. So we store all the data that was in the Excel data sheets. We store that in MongoDB, and we query that, and we look it up on the fly, which I'm going to talk a little bit about here on the next slide. But it's become this kind of platform where all the development around our automation is centered in this one place. So let's look at a comparison between kind of the old model, what I'm calling the old model, and this new engine-based approach. So this is kind of the old model, where if you have a flow that has a bunch of different steps in it, let's say in this case there's about 25 steps. Each step needs its own control, and you have to configure that control. If you have endpoints, you have to set those up, asserts, filters, all those things, you do that times however many steps you have. And there's a little bit of reusability in terms of, you can add some variables and have some configuration files, but overall the reusability isn't as high as what we wanted it to be. Because if I have another flow that's similar to this, but has maybe 30 steps or 15 steps, I have to subtract or add steps and then customize those again. So let's compare that with the engine. So in the engine, basically we've simplified everything down to whatever we do at one time. If we look at this in terms of a loop, and we talk about MongoDB, we're storing everything in MongoDB. We look that up as needed. So someone tells the engine, I'm going to run this test in this environment. I go and query for that data, I retrieve it, set up the variables. Those variables build on each other. So if query A sets up a few things, query B then can go and use that data then to go and look up its bits. And so we've broken all of the test data that we need to drive these automated tests into functional pieces, like everything that's related to environment, that's in one collection of information. Anything that's related to test data, that's in another piece. And so it makes a lot more logical sense when you're developing automation to break it down like this, and you can reuse those components in other tests. If I know how to call an API, and I've got 30 different flows that call it API, I don't have to do that again and again. I've just reused the data that it's driving the engine. I just also want to show a little snippet of what the data looks like that's in Mongo. So basically, this is kind of a small sample for the test cases. It's a CSV file, and we're storing that in our source control. Everybody is already kind of familiar with Excel from the previous approach. They know how to go and kind of create test cases in that way. But then we're using kind of a pipeline approach where you check in your changes to source control. Those changes then get imported into MongoDB. So if I write new test cases, I write them in this format, check them into source control, that automatically kind of percolates through the system and ends up in MongoDB. Now I can go and query that. I can also do it locally, so I can have a local setup, go and test everything out, make sure it works, and then I can go push that to source control, have it go live. And if you kind of look at the order of these steps, you'll see that we're mixing and matching web service calls, database queries. We've got custom steps in there. It's really kind of allows you to create a recipe and mix and match whatever you want in any combination you want. So this engine right here can easily do this 25 steps. We've done 50. There's not really a limit in terms of the number you can put together. Because it allows you to kind of save data, pass data, and just kind of continue. So now I want to show kind of a little bit more about how we're leveraging the MongoDB in terms of data simplification. So we already kind of talked about some of the benefits. In terms of the challenges we're trying to address, we wanted to reduce how labor intensive our data management was. As I mentioned before, we started with a lot of Excel data sheets. There's a lot of data management involved with that. By reducing the redundancy and kind of getting all that into a single instance of data, made it a lot easier to manage that. And also, we had a lot of hard-coded strings before. We went away from that as much as possible. So everything is very parameterized now, which allows us to add new test environments or make things a lot more dynamic and flexible. So in terms of the solution, as I mentioned, we've centralized all the data. It's simplified. It's easier for people to kind of develop their tests using this model. And just as a demonstration, we have 6 collections, 6 files basically that determine whether something's environment, test cases, test data, response validation, API inventory, and headers. That's it. So anything that you want for your tests goes into one of those buckets, and that gets pushed into the database, and then we look it up for you on the fly. Okay. So this gives us easier maintenance. Obviously, it's queryable. It's in a database. It's parameterized, as I kind of mentioned before. It's a lot more flexible because we're just changing the data. The automation behind it doesn't change unless we find a defect or we add a feature. That engine kind of stays static, and we're just changing the data to fit the scenario that we're trying to test. And lastly, in terms of migration, if you already have a bunch of Excel files and you're trying to move to this model, MongoDB supports importing CSV files and JSON files natively. And we had a lot of Postman collections that we were using for kind of sanity checks. So that allowed us to kind of reuse that test collateral. We just import it into MongoDB, query for the name of the API, we get the request payload back, easily gets reused in the automation. Okay, so now I just want to give a little bit of an overview of all the pieces kind of put together so you can kind of see how these things are working. So in this picture, in the middle, that's the CASV server. Hosted on the server, we have our execution engine. We have a logger engine, basically using the same approach, but for logging. And what we're using to drive that is the green box. So we're using these CA REST APIs, the Lisa Invoke APIs, to pass data to our script engine. So that data we're passing it is little clues for it to go and do the lookups in MongoDB. So we pass it stuff like what environment, what test cases. It goes and does all the rest for you. It goes, okay, I know I'm testing in this environment. I know how to look that up. I know what test cases to look up. There's nothing else for you to do. And the big win for this is, we talked about the test pipeline before. That's sort of the static kind of gives you a baseline. This is more of a dynamic kind of approach where you can be event driven, you can be operating on a code change. It's very dynamic and flexible at runtime. You can tell it to look things up. So now we kind of have this both best of both worlds where we're getting static kind of reports a couple times a day based on our pipeline, and we can go and drive tests based on code changes or anything else that we want to do. So in terms of just on the right there, we kind of have this just basically a little cheat sheet. We've got our single engine for logging, single engine for execution. So it gives you one place to update all your code in terms of defects, in terms of enhancements. Less redundancy, gives you that static execution capability, the dynamic execution capability. We've got centralized data, standardized, and it's data driven with kind of reusable and kind of a flexible approach. And all those tests are very shareable so that you can reuse components without having to redo all of that. So I'm going to turn it back over to Suzanne, and she's going to kind of summarize and highlight some of the value that the new approach has offered. I'll let you.
So as a product owner, what's important to me? Well, it's what's the value that this new solution has brought the company, right? So there's actually 3 areas of value that I want to cover with you. The first is reducing a footprint. So originally, the footprint of the original solution was about 16 megabytes. With Jason's solution, that was reduced down by 88% to 2 megabytes. So a very small footprint. The second area, So not only does the footprint, but the file sizes. So we were dealing with 927 files in the original system. So think of that when you want to maintain it and you have some changes. So we went from 927 files down to 60 files, a 94% reduction. And so that leads us into our second value statement, which is maintenance. So managing and maintaining the automation tests went from 2 days for a change to 30 minutes. So there's big value there. It was so much more efficient and less costly to maintain. It really was paying for itself immediately. So the third area of value was test execution time. So before the new approach, you heard Jason, it took us 5 days, 5 resources, and we could only, we executed sequentially. We could cover one environment at a time. So it was very costly. So after the new solution was brought in, we were able to reduce our cycle time, and we could execute 2,000 tests in 1 hour across multiple environments. So if you want to look at our savings of 240,000 hours in a 6 weeks cycle time, and now we're running against multiple environments, we're using parallelism, starting to really move that needle like we want to see in our DevOps, right? And so I think with this solution, we really were able to show the value by getting automation put in place, not only for testing, but also for the process.